The size of the antigen that you use to make protein antibodies is a very important consideration. On one hand, if you use a very large full-length protein antigen to immunize, you elicit antibodies that can recognize the conformational shape of the properly native folded protein, and this is a very good characteristic of an antibody. And antibodies that can recognize native protein structures are often useful in very high value applications like sandwich immunoassays and flow cytometry and even functional assays. However, it's often the case that you don't really want to have an antibody that just binds to a protein antigen, but that you want the antibody to bind to a very specific region of that protein. And when you immunize with a full-length protein, at least conceptually, we can imagine that antibodies could be made to any portion of that protein antigen. And so when you immunize with a full-length antigen, and if antibodies are made to any region of that protein, well, then we don't really know where the antibodies are binding. And so that's a limitation with immunizing with full-length antigens. That is that we don't really know where the polyclonals are binding or where even the monoclonal antibodies are binding. Now, there is an additional consideration when using full-length antigens, and that is, while conceptually we can imagine antibodies to any portion of that full-length protein, the immune system exerts a phenomenon known as immunodominance. And so antibodies aren't made to every portion of the molecule. Antibodies, the immune system focuses antibody development on a limited number of regions of the protein. Say 3 or 4 or 5 regions are immunodominant. And so if the region that you're interested in is not one of these immunodominant regions, then you can continue to immunize over and over again. But if that region that you're interested in is not immunodominant, there is a possibility that you will not get the antibodies that you're interested in. Now, on the other extreme, you have very small antigens like peptide antigens. And the peptide has the advantage in that you know precisely where the antibody is going to bind because you made the small peptide fragment, and if antibodies are elicited to that fragment, well, you know where that antibody is binding. But the disadvantage of the peptide antibody is that the peptide being so small, it does not adopt a defined native conformation that exists in the larger protein structure. And so that the antibodies that are elicited using a peptide approach, while they have the ability to, target where you want the antibody to bind, you do not elicit the quality of antibody that is very useful in high-value applications like sandwich immunoassays or flow cytometry or functional assays. So to address these concerns, we developed the genomic antibody technology. And in the genomic antibody technology, the immunogen is the size of a protein domain. That is, it's approximately on the size of about 100 amino acids. It can be larger, it can be smaller, but approximately 100 amino acids. And because protein domains fold independently of one another, there is a much higher probability that by using a protein domain, or approximately 100 amino acids, that structure will fold into the correct native conformation. And therefore, when you use that, you will elicit antibodies that can recognize native protein structures. And therefore, those antibodies can be useful in some of these higher value applications like sandwich immunoassays. In addition, you get the benefits of being able to target where you want the antibody to bind. So you could target intracellular regions of a protein or extracellular regions of a protein. And you can also, by using this technique, target the antibody binding to areas where there are even just single amino acid changes. So the advantages of using a protein domain or a 100 amino acid fragment are that it's bigger than a peptide so that it folds into proper native conformational structure and elicits antibodies that can recognize these structures. And yet it is smaller than full length, and so it allows you to be able to target where you want the antibody to bind.